You have the value of a stock for the next N days. Given that you can only buy or sell at most one share of the stock each day, maximize the profit you can make after N days. Hi everyone, we're here today for another Exponent mock interview with Lewin. For those of you who aren't already familiar with Exponent, Exponent helps you get your dream tech career with our online courses, expert coaching, peer-to-peer mock interviewing platform, and interview question database. Check it out at tryexponent.com. All right, thanks so much for being here with us today, Lewin. Would you quickly introduce yourself for our viewers?
Yes, so I'm Lewin. I'm currently working at a small startup for machine learning called Forethought, and I'm kind of here to just show you how I'll approach interview questions.
Great. We're really happy to have you here today with us. Okay, so our question today is, you have the value of a stock for the next N days. Given that you can only buy or sell at most one share of the stock each day, maximize the profit you can make after N days.
Okay, so yeah, I guess first I can start with like a function signature, so max value or max profit for like stock prices. For some clarifying questions on like, I guess, do you start with like a limited amount of money or like,
No, you can assume that you basically have an infinite amount of money to buy stocks with, and you just want to make the maximum profit possible.
Okay. And can I assume like, I guess the prices will like all be like positive numbers, I guess?
Yes, you can.
Okay. And yeah, I'm trying to think of other edge cases just off the top of my head.
Yeah, that's great.
Yeah, I guess, do you have to buy or sell? Like, can you do nothing, I guess?
Yes, you can do nothing.
And I guess this one is maybe not too important, but like, can you buy and sell in one
No,
day?
you can only engage in one transaction, so either a buy or sell per day.
Okay, or nothing. Okay, all right. Yeah, I think, okay, yeah, so given these constraints, the first approach that comes to mind is kind of like a dynamic programming type solution. So basically we'll go through the days one by one, and we'll try to see what's the maximum profit we can make given we're on this day and we have like this amount of stock. So
Yeah, okay. So that implies that you're going to reuse past results somehow, right? How do you plan on doing that here?
yeah, so like the first step is just kind of defining the state. So like the final, I guess, like, can you end or like, do you have to like sell all your shares after end days? Like, can you have any leftover shares?
You can have leftover shares.
Okay. So final answer is basically like max of VP of n minus one, which is basically like the maximum profit I can make on the n minus 1th day over all the indices, like over all the number of shares I can have.
Yeah.
So yeah, I guess for dynamic programming problems, like usually you, yeah, so yeah, we'll need to define like kind of like the state transition for this next, and maybe like the base cases. So we can start with base cases because that's easiest. So we can, so let me just initialize this, and I'll just set like negative, like I'll just set like infinity. Like let's say something big for now. Maybe we can change it. So sorry, this should be our inner loop, this outer loop. We can have at most n plus n shares, so I'll just add +1 here. And then we're just going to do this one by one. So initially I just set it to a very large negative number because they're all impossible first. And then our base case is I start on the first day with 0 shares. And this is just equal to 0. I have made no profit so far.
Right.
Yeah. So I guess let's make this one index because it's easier, because like on the 0th day, I passed 0 days so far. So basically I want to do like for I in range +1. So on this day, I will stock prices I -1. So I subtract 1 from here because the list is 0 base or 0 indexed. And then I'll just keep this in a variable current price so it's easier to access later. Basically, there are 3 different actions we can take in each day. So I'll kind of write it out. I'm not too sure what my inner loop is yet, so I won't write it first, but like I will fill in what the inner loop is.
Okay.
So given I'm on this day, I can sell 1 share of the stock. So I want to, I'll just do dpij. I look at the previous day. So if I sold 1 stock, that means the number of shares I have is going down, or like it's less than 1. So like I think I add 1 here. I might be wrong, so I can fix this later. So basically what this means is if I sold a stock from the previous day, that means I've started with J plus 1 shares, and I lose 1 share to get J shares. And then I gain a profit of current price.
So you're saying on the previous day you had J plus 1 shares?
Yeah. So basically I'm trying to compute dpij. This is the first case. The second case is I do nothing. So I have the same number of shares. I lose 1 stock, or I keep the same number of stocks. And then the last transition is I buy 1 share. So if I buy, then that means I started with J minus 1 shares and I lose this much money. Yeah, so I think these are like the 3 transitions. Like this is max of sell, do nothing, or buy. And then now I just need to wrap this in an inner loop. So I might have some out of bounds errors, so let me try to fix them. So in this case, this just means I sold the stock. And then this is just bounds checking. And then if it's at the very edge, I'll just set it to negative infinity. This is like nothing.
Okay, so we're taking the max of the profits that you would get from each of the 3 actions, right? Sell nothing, do nothing, and buy.
Yeah. So now the important thing is just to make sure we've computed these DP states before. And like, since these are all just accessing the previous index, like I minus 1, they've already been computed in the previous iteration. And then
not the case for J though, right?
Yeah, for J, that's not the case, but I mean, we're always looking at I minus 1. So like I minus 1 has been completely filled before.
Yeah,
so it's okay. Yeah, it's okay. J is -1 and +1.
Right.
Yeah, if this wasn't I minus 1, then we would need to do something different, but I think we don't need, I think this current loop ordering is correct.
Yep.
And then yeah, at the end, I think we just return to like max P. In the sense this is 1 index, we do n. Because we've finished n days. And then we take the max overall that we can do that. Okay, so I guess I can try this out and just make sure it works. So maybe a very simple example. In this case, I guess optimal answer is like buy 1, buy 2, sell 3, sell 4. So this should return 4 because we
Mhm.
bought at 3. We bought our total buy is 3, total sell 7. Let's just see. Okay, yeah, so prints 4. Maybe another example where we actually want to do nothing. So like do nothing. So it should
Right,
return 0.
because the price is only ever decreased, right? So you can never
Yeah.
make profit.
Yeah, so this returns 0 as well.
Perfect.
Yeah, so I think that looks correct. I don't know if there's any other examples we should go over as well.
That looks good to me for now. What happens with like an empty list though?
Yeah, so let's try that out. Print 0 as well. And I think that's correct because we don't have any stocks to share
Right,
or to sell.
exactly.
Yeah.
Yep. Okay, great. So this looks like a pretty good solution to start with, but what would the runtime and space time be?
Yeah, so this is an n squared solution just because we have this double loop. And
Mhm.
then inside this loop, this is all constant time because we're just doing constant time comparisons.
Mhm.
So it's n squared time.
Yeah,
Oh,
and
yeah.
so what would the brute force solution runtime have been?
So the brute force solution is you probably just like iterate through every subset that you buy or sell.
Yeah.
So that would be like 2 to the n, potentially, maybe even more because
The exponential.
yeah, it's like 3 to the n probably because you have 3 choices at each time.
Mhm.
But yeah, the reason this is a lot faster is because we reuse a lot of the state here. So like these are all constant time lookups. So it doesn't blow up.
Yeah.
Yeah, and for space, it's also n squared. So we could optimize this to O event space because like we only look at I and I minus 1. So we don't
Mhm.
actually need to keep track of every single row of the DP table.
Right.
Um,
You only need to keep track of the previous row, basically, right?
yeah, we only need to keep track of the last 2 rows, like I and I minus 1.
Yeah. And the current, yeah.
Yeah.
Mhm. Okay, so it looks like it's already much more efficient than the brute force solution. Is there anything you would do to try and make it even more efficient than this?
I guess there is, so like the slow part of this solution is that we have to keep track of the number of shares as like the second index in our DP table. But instead, we might try to think of like a greedy solution. So yeah, I mean, maybe a very simple greedy solution is like every day I look at all the previous days and then I see like what's the cheapest stock I can sell at, and then just make that transaction. So the problem with that greedy solution is it fails on a case like this because here, when I see 2, I'll say like, oh, I can buy at a stock at 1 and then make like buy at 1, sell at 2. But actually what we wanted to do is like save the 2 for later, or like we wanted like, because there's like even bigger numbers later down the list.
That you could sell at, right?
Yeah, that type of greedy solution doesn't quite work, but I think, yeah, I guess like one way we could try to fix it is we can introduce like maybe a notion of like, I mean, the greedy solution like basically keeps track of like what options we have available previously. So we'll introduce the notion of options. And like options is a normal financial term, but like basically the idea behind those is I can always go back in time and buy a stock at a lower price. So
Mhm.
like every day, basically I gain an option with the current value, but I don't have to immediately buy that,
Uh-huh.
buy that share. So what I can do is instead, when I find something that gives me, that has a higher price, I can say, okay, I'll actually like pretend to go back in time, buy that stock, like buy a single share of that stock, and then I can just sell it at this day. So it's kind of like the principle that the greedy solution is working with, but it doesn't quite work because sometimes we'll make the wrong decision.
Mhm.
So we need to somehow account for the fact that like when I see this 2 and I want to make this like transaction, I still want to keep track of the fact that like maybe in the future I can actually make a larger profit by holding the share for longer. So yeah, I think maybe I can sketch out like the very naive greedy solution, and we can see how to fix it. So
yeah, maybe good to see an example.
all right, so the idea is we want to keep track of a set of options. So initially we have no options because we haven't seen any stock prices. So basically, like options contains stocks that we could go back in time and like buy at. So this way we don't need to keep track of the number of shares that we currently own. We only need to keep track of the set of options. Basically what I want to do is like add a price to the options. Or maybe at the very end, I can first see if I can. Basically, I want to answer this question and then just say like, if I can make a profit, let's just try to do it directly. So I'll like try to keep track of the current profit. And to do this, I'll use a heap because basically a heap is useful because I can always pop off the cheapest element from
the top of the heap.
From the top, yeah, and then it's log n rather than having to search through the entire list. So I think Python has a heap library, and then basically it's ordered. It just happens like the first element is the smallest weight one. I mean, it's not in sorted order necessarily. It's just like in heap order, but it just happens like the cheapest one is on the top. So if like price is bigger than cheapest, so this just means like I sold a stock, or I basically kind of went back in time and like bought a stock at this value, and then added to my current price. Add my current price to the set of options I have. So this is kind of like the naive greedy solution I was mentioning. Basically, if I can make a profit, I'll just greedily find the cheapest one, add it to my current profit. Otherwise, I just add this to my price, add the current price to my options. So I think it'll fail on this one, as I mentioned. Let's just double check, make sure.
Right, yeah.
Yeah, and this returns 2, as I said, because the problem here is
it immediately tries to sell, right? Yeah.
Okay, so basically, the way we can fix this is I still want to remember that if I bought at 1 and I sold at 2, maybe I actually want to sell the 2 at a later point. So I think if I just add at the current price, that should help fix it. So basically, this is saying maybe I want to buy what I immediately sold at a later point.
Yeah, so it's almost like you never bought and sold it the first.
Yeah. Right. But this is actually like doing no transaction at this point then. Like if I choose to use this at a later point, I can actually maybe buy 2 at a later point as well. So I actually need to add this twice. Because like I can just pretend I never did anything.
Yeah, so it's like you can go back and undo that action.
Yeah, and the price actually happens to work out, right? Because like B minus, or like if I have like plus like b minus a.
Plus
This is
minus.
equal to like c minus a, right?
Yeah.
These of these cancel out. So this is kind of like saying in the future, maybe I'll get rid of this. And this is just because I can buy like current price later. So yeah, if I add it twice, I think then it also returns 4 as well. Yeah, so I think that's all there is. I think this should be good.
Okay, yeah. Can we try a few more test cases?
Yeah, so maybe I can try the ones I had before. I don't know if you have any bigger ones in mind. I can also try as well.
Yeah, maybe we could try some where there's like different amounts of profit, because right now each of the cells results in 2 profit.
Yeah, so I mean, let's try, I guess there's like an example like this maybe. So this should return, it should be 9 plus 1, which is 11 or 10, right? 9 plus 1 is 10. I don't know, maybe I could have like things in between. So this should still be 10, I think.
Yeah, because it should
because I just do nothing at 4.
Yeah, it'll basically undo it at 4. Yeah.
But maybe or let me make a new case for this. If I had something like this, actually, like maybe I want to buy 4 and sell it later. So this should be 9 plus 5, which is 14. And it also returns 14.
Yeah, so it looks like the solution works pretty well. So what is now the new runtime and spacetime complexity of this solution?
Yeah, so the runtime, so basically we have this loop for going out through stock prices is O of n, and all the heap operations are log n. And at every, like in either case of this statement, I'm only increasing the heap by like length 1. In this case, I'm removing 1, then adding 2. This is plus 1. In the other case, I'm just adding 1. So the heap is only growing 1, like the heap size will be at most O of n. So the space is O of n. And then the heap operations, there's O of n total heap operations. Each of them take log n time. So this is n log n runtime.
Yeah, okay, perfect. All right, so I think this is a great place for us to pause. You did an amazing job. This is a really interesting question, and we came up with a really good solution here. So I'd love to hear your opinions on how this interview went. What do you think went well, and what do you think you would want to improve on?
Yeah, so I guess I kind of just jumped into the DP solution. So, I mean, I think, yeah, maybe I could have went through the brute force first just to kind of show what it looks like. And then, yeah, I think I originally tried to do this all inline, but I think separating it out into variables maybe a lot easier to read.
Yeah, that's definitely helpful.
Yeah, so that was good. But yeah, I think like if I was kind of like guessing on like these bound like ranges initially, so I wasn't sure. But I think like for DP solutions, like if you write the transitions, then like I was kind of working backwards. Like usually I write the transitions first and then figure out like which order I should loop in. I was trying to do it the other way, which maybe it was a little bit confusing. But yeah, and then the greedy solution, I think, yeah, like just going through more examples maybe would have been helpful. But yeah, I think it was okay overall.
Yeah, it definitely was. I thought you did a really great job. You managed to get through 2 different solutions, and both of them were really excellent, clean solutions. And I liked how you explained like what the inefficiencies were in the dynamic programming solution and how you could actually remove those and get the greedy solution instead. Yeah, and you also did a really good job of like asking clarifying questions that actually change potentially how you would implement your solution. So, for example, like whether or not there's a limit on the amount of money you spend, or whether you can do multiple buys or multiple sells in the same day. You know, those are really important things to ask. Yeah, and I also like that you broke down the logic for the dynamic programming solution into those three cases of like sell, buy, or do nothing. That made your solution much more clear. But yeah, I also agree with you on the fact that you jumped right into the dynamic programming solution in the beginning because I guess you already know this problem and you knew how you planned on solving it. But I think in an interview, it helps to explain your thought process of how you came up with a dynamic programming solution in the first place. Like, why should we use dynamic programming? Typically we can identify when a problem is a DP problem because it has overlapping subproblems, right? And so it would have helped for you to first like maybe work through a few examples and explain in those examples what are the overlapping subproblems, before then plunging into the coding. Yeah, same feedback for the greedy solution, I would think, because I think it's a very clever solution and I maybe would not come up with that right away. It's like something that you would probably figure out via like a few examples, and that also acts as a great way to communicate your solution too. Yeah, and I also really like the way that you wrote your code. It was very modular, very well documented, super easy to read. So thanks so much, Lewin. That was great.
Yeah, thanks for having me again.
Yeah, thanks everyone for watching and good luck on your upcoming interviews. Bye, everyone.
Thanks so much for watching. Don't forget to hit the like and subscribe buttons below to let us know that this video was valuable for you. And of course, check out hundreds more videos just like this at tryexponent.com. Thanks for watching and good luck on your upcoming interview.